Okay. Next exponent rule here. What do you do when you have a power or an exponent to a power? Okay, well, what that looks like is, let's say that we have A times B to the M power, and then all of that is to the N power. Okay, well, that means you have a lot of stuff on the inside of parentheses to an exponent. All right, so that is a power to a power because you technically have an exponent that's brought to another exponent. So when that's happening, so when you have a power to a power, the rule there is you actually multiply the powers. Okay, so remember, when you have a couple things on the inside, like, do you see this A does not have an exponent? Remember, we talked about when it doesn't have an exponent, it has a hidden exponent of 1. So this is technically A to the first, B to the M power, and then all of that, because it's in parentheses, would be to the N power. So when you have to do this rule, it's almost like you're going to distribute this power to all the other powers in the parentheses. So you're distributing exponent to exponent. So like if I did this, it'd be like N times 1 and then N times M. So it's almost like it's distributing. Okay. So the bases stay the same. So it's still going to be A, but then it's going to be to the whatever 1 times N is. And so remember, 1 times anything just gives you whatever that number is. So 1 times N would be N. And then you've got to do the same thing with the exponent that's with the B. So it'd be B to the whatever M times N is. And now, because we can't actually simplify that, we just write it like that. Okay, so that is the power to a power rule. All right, let's apply it now. Yay, lead. Gotta love lead. All right, so we've got x squared times y to the third, and then all of that is to the second power. So when you're doing this one, notice you've got a couple things on the inside of the parentheses that have their exponents, and it's all to another exponent, power to a power. So just like we did over here, you have to multiply. It's almost like you distribute this power that's on the outside to everything power-wise on the inside. So this would be x to the whatever 2 times 2 is. And then this one would be y to the whatever 3 times 2 is. Okay, so you distribute your power to each of the powers. And then you just simplify. So this would be x to the, well, 2 times 2 is 4. And then y to the 3 times 2 is 6. And so since they were multiplying to begin with, it'd be x to the 4th times y to the 6th at the end. All right, so let's do one more of these. And then we've got one more rule after that. So let's say we have 8a to the negative third power times b to the 6th. And then all of that is to the negative third power. All right, you got a lot of stuff going on in here to the negative third power. Just like what we did in all the other problems, if you have a power to a power, you multiply the powers. But we do have a hidden power in here, so hopefully you noticed it. This 8 does not have an exponent with it. So because it does not have an exponent with it, you've got to put the 1 with it, because if you forget that, you will forget to distribute that power to all the powers that you're supposed to, okay? So just like what we did in the other problem, you're going to take this negative 3 times each of the powers that are inside the parentheses, okay? So this 8, even though it's a regular number, it still is inside that parentheses. So you have to do the same thing to its exponent. So this would technically be 8 to the whatever 1 times -3 is, which is -3. And then it would be a to the -3 times -3. Well, negative times a negative is a positive, and then 3 times 3 is 9, so it would be a to the 9th. And then the last one, it would be b to the 6 times -3 would be -18. And so there we go. Now, we actually will come back to this problem in a minute because it's not actually all the way simplified according to exponent rules. And so we will come back to it after we learn our last rule. Okay, so we got one more rule to learn. And so let's learn it. All right, the last rule that you have to learn is what to do when you have negative exponents. Because a lot of times with these exponent rule problems, you will be asked to write it so that it does not contain negative exponents. And so you've got to know what to do when you have them. All right, and so that's supposed to be exponents. All right, so let's say that we have the base with a negative number as the exponent. What you have to do to make it positive is you'll always hear me say something like, you move the negative exponents. And so what I mean by that is you have a fraction always with these numbers, no matter if it's a number, a variable, or whatever. And so when I say you move, you actually take the base and its exponent and you move it to whichever side of the fraction it is not on. So like right now, this is actually technically on top of a fraction, because remember, every number is technically understood to be over a 1. And so when you have something like that going on, to make the exponent positive, you actually have to take it and move it to the other side of the fraction. So since this is on top of the fraction, it'll actually move the base and its exponent will move to the bottom of the fraction. And so when I do that, remember I move the base and its exponent, the actual thing that will, or the thing that will happen is that the exponent will become positive. And so notice when I moved it, now it's a to the m power. Okay, and now you might say, okay, well, we don't have anything on top of the fraction. Well, remember, if you don't end up with something on top of the fraction, you just put a 1 on top. Okay, so when you have a negative exponents, so let's write down this description. If you have negative exponents, then what you're going to do is move them, the base and its exponent, to the other side of the fraction. Okay, so let's practice that. Let's say that we have y to the -4th power. Well, you don't want negatives as exponents. And this is y to the -4th. It's not on the bottom of a fraction. So that means that this is technically kind of like this scenario. It's on top of a fraction. So to make that exponent positive, you have to take the base and its exponent and move it to the other side. So to make it positive, we're going to take the y and the -4 and move it to the bottom. But then the 4 magically becomes positive. Okay. And then remember, if there's nothing on top of the fraction, you just put a 1. Okay, let's do another one. So let's say that we have, let's do this one. So let's say that we have x to the 1st, which remember I don't typically have to put that, over x to the -2 power. All right, this base, this x, actually has a positive exponent. So if it's positive to begin with, you actually leave it the way it is. But the x that's on the bottom has a -2 as the exponent. So that one will have to be moved to the other side of the fraction so that it will become positive. So you also could, as a strategy, kind of visually, it helps you. You could actually circle the base and its exponent, and you can draw a little arrow to where you're trying to move it so that you can kind of understand what's going on there. And so when I move the base and the exponent, it will all move to the other side of the fraction. So this is a little different because it actually has to move to the top to become positive. And so this x to the first actually stays on top, and then the x to the -2 will now move to the top, and now that 2 will become positive. All right, now to actually finish simplifying this, however, this brings in another rule that we've talked about. So if you remember up here, when you are multiplying like bases, so this one right here, you have to add the exponents. So because we're multiplying these, we have to actually take their exponents and add them. So this would actually end up being x to the 1 plus 2 is 3. So it'd be x to the third power when we're done with it. Okay, let's do this problem up here, and then I'll do a little bit, or one that involves a couple different rules so you can kind of understand how that works. So with this one, the reason why we had to come back to it is because notice you have negative exponents. And so with those that have negative exponents, you have to actually move them so that they will become positive. And so the 8 has a negative exponent, so it will have to be moved. The b has a negative exponent. It will also have to be moved, but the a does not. So it'll actually stay on top of the fraction. So both the 8 and the b will be moved, and the a will stay where it is. And so if you, again, want to visually kind of draw yourself what's happening, you can. And then we're just going to move them. So when I move it, the a stays on top. So I'm going to go ahead and write my a to the 9th on top. And then on the bottom, the 8 to the -3rd will go on the bottom, and it'll magically become 8 to the 3rd. Let me zoom in just a bit. And then b to the -18th will now become b to the +18th. All right. Now, the only other thing that you will have to do here is, because remember I said you've got to treat numbers like regular numbers, 8 to the 3rd will simplify. So if it simplifies, you have to simplify it. And so 8 to the 3rd, that's a little bit harder one. But remember, you can use your calculators on the exam. So if you need to type it in, you can. But 8 to the 3rd would end up being 512. And so now everything has a positive exponent, and we've simplified all the numbers that need to be simplified. And so there we go. There is our answer for that. All right. So hopefully we're doing okay so far. Let me see if there's one that's a little bit of one that would take multiple steps, and I'm kind of running out of room on the front side of my exponent rules. So I'm going to flip to the back, and I'm going to show you a way or a strategy that you can use to do some of the harder, more involved problems. Okay, so let me flip over, and if you need to kind of rewind this video, remember you can always rewind or replay whichever parts you want to replay, so that you can refresh your memory. All right. So the thing that you can actually use to kind of remember how to do maybe some of the problems that are a little bit more involved is you can remember this simple acronym, and some of my ladies will know this a little bit more maybe than my fellas, but this lovely little acronym, PMS, will actually help you remember the steps to simplifying these problems. And so, yes, it stands for something else in the outside world, but in math world, it helps us learn how to simplify using exponent rules. So the P in the math world stands for power to a power. So this is actually the first thing you want to do when simplifying harder problems. The next part, the M, stands for move negative exponents, or the ones that have negative exponents with them. Okay, so that's actually the second thing you want to do. And then the last thing that you'll do is simplify anything that's left. So any of the other rules that need to be done, or if you need to simply simplify numbers, like we did that 8 to the third, then you have to do that. All right. So let me show you a little bit of a harder problem so that I can show you how to use these. Okay. So let's say that we have 4x to the negative 2 power y, and then all of that is over x to the third y to the negative 1 power. And then all of this is to the third power. So when we start simplifying this, we have to follow these rules. So the first thing I'm going to look for is the power to a power. And notice we have all of this to the third power. So we definitely have a power to a power. So the first thing that I want to do is use that rule, which remember, power to a power, you have to multiply the powers. So look for those hidden powers first of all. So like my eyes automatically go to the 4 and the y because they don't have an exponent with them. So I'm going to go ahead and draw the 1. That would technically be the exponent with them. That way I don't forget about that. And then I'm going to do the power to a power rule. So remember, you literally take, and I told you it's kind of like distributing that power. So you take that power times every single power that's in here. So now notice, not only do you take it to the powers that are on the top, but you also actually have to take it to any of the powers that are on the bottom as well. Okay. So when I do that, and I know that looks like a mess, but hopefully that makes sense. So when I do that, it'd be 4 to the 1 times 3 power. And then you have x to the negative 2 times 3, which is negative 6 power. And then y to the 1 times 3, which is third, or to the third power. And then you have x to the 3 times 3, ninth power. And then you have y to the negative 1 times 3, which would be negative third power. All right. So hopefully that kind of made sense as to you distribute your power. Then from there, if you have negative exponents, then you move your negative exponents. So you have 4 to the third, so that doesn't have a negative exponent, so it won't move. Then you have x to the negative 6. That has a negative exponent, so you've got to move that. Then you have y to the negative third. That has a negative exponent, so you've got to move that one, okay? So now notice these that don't have a negative exponent are going to stay where they are, okay? So if you want to go ahead and leave them and write them as your fraction, like this y to the third is going to stay where it is. The x to the ninth will stay on the bottom. So you can go ahead and leave them. And then these, like this one, will move to the bottom. So I'm going to go ahead and move that to the bottom. And remember, the reason you move it is so it becomes positive. And then this y to the negative third is going to move to the top. So the y to the negative third will move to the top, and the 3 will become positive. All right. So now after that, you simplify anything that's left. So this 4 to the third will simplify. So 4 to the third is 64. And then notice you have like bases and you're multiplying. So the rule there is you add the exponents. So 3 plus 3 is 6. And remember, it stays an exponent. And then on the bottom, you've got x to the ninth times x to the sixth. So again, when you multiply like bases, you add the exponents. So 9 plus 6 would be x to the 15th power. And then you look, is there anything left over to simplify? Well, we've simplified our numbers. There's no more like bases. And so this would be our final answer. So hopefully that helps. Remember, you can always pause, rewind, replay anything you need. And please, please, please don't forget, if you have questions, always, always, always ask. You can email, you can put it in the class comments section. But good luck with your homework, and until next time.